Hello everyone and welcome back to the channel. Today we have a washing machine main PCB board. It's from a Bosch Siemens washing machine. It should be common in a few models. Here is the part number. Unfortunately, I only have just this PCB, but the customer complaint is that there is no power. The washing machine does not turn on. That makes it easier for us to start testing the primary and input side of the board. So let's get our multimeter about here. We should be able to see both of them. So here is the neutral and live input to the board. And this is a fusible resistor that feeds the bridge rectifier. So first thing to check is, and as you can see, this resistor is in mega ohms, so it definitely is open. As you can see, this is orange, white, black 5% joby. So if this is open, we probably have a short further down the circuit. Let's check the input side of the bridge rectifier. No shorts there, and let's check the plus and minus. And as you can see, we have about 18 ohms, so most definitely we have a short here. Now the problematic parts may be the input capacitor or the tiny switch, this IC here, which has the MOSFET built in. And if we check between drain, we can see we get a lower reading there. So in order to check the bridge rectifier also, I will have to remove the capacitor and try to remove the tiny switch, this IC, and see if the short is gone from the PCB. So the desoldering iron is ready. Let's remove the resistor, both the capacitors. I will add a bit of solder to help the PB free solder to be removed easier. So here is resistor. let's give those a test. So this shows an odd number. I will check with a different capacitor tester because I have seen that before, but I think the capacitor is okay. Let's check the other one as well. So this is 470, it shows 530 with 0.04 resistance. This capacitor is absolutely fine. Now I want to add a bit of flux and solder to this IC to be easier to remove. And those two, and that one. Because I want to avoid using the hot air there, I will try maybe to remove it with two soldering irons. Will it be possible? Yeah. So there we go. Now let's see if we get the same measurements. And as you can see, the short is gone. Check the drain and source here. As you can see, 1.4 milliohms. The short is definitely gone. Now when you need to check all the diodes in our bridge rectifier, and for that I need to switch off the desoldering station as it does a lot of noise. There we go. So in order to check our four diodes in our bridge rectifier, I'm going to put the positive. First of all, I'm using the diode test mode in the multimeter. Put our positive probe to the minus and check both the AC inputs. That's one diode, two diodes are fine, and then we switch the probes and use the negative on the plus sign of the bridge rectifier. And that's it. So now we know our four diodes here are okay, and we may proceed to replace the resistor, if I manage the resistor and the IC, and we should be ready to go. Now, because I've seen some odd readings from this transistor tester, I'm going to use the old one just to verify, get a good contact, start the power supply. So there we go, 1.9 ohms. It is absolutely fine for a 10 microfarad 400 volt capacitor. So we are going to use the same one. Now let's clean our pads. I forgot to say that this is part number, so this is TNY267. Is it possible to TNY267GN. Now this is our 2 watt Joby resistor. It is slightly, let's put it on the same side, slightly bigger than the other one. It should be okay. And our IC. Now what I like to do is I'm going to use a little bit of flux on the pads to help the solder flow. Just verify we have the correct part, and we're going to place it in position. Because now I have the flux, I will, but my tip doesn't have any solder, so there we go. So that looks straight. Just flow one pin to keep the IC steady, and double check the position. It looks right, and I'm going to go ahead and solder the other pad as well. 1, 2. I'm going to try to zoom in. There we go. It's not pretty, but all the pads are connected. Now let's put our resistor back on. Unfortunately, this is not a fusible resistor. Again, it should be fine. It is in an enclosed plastic box, this PCB. In case someone cannot find the 39 ohm resistor, you could use two 18 ohms in series to get the same result. I'm going to use some 99% alcohol to clean the area here. Same one here. Now don't forget our capacitors. Now here, even if we don't have a marking, we can see that it goes to the minus of the bridge rectifier. There we go. That is nice. And the second one was with a minus sign here. So there we go, everything is back in place. Let's see if there is a way to test it. Here is our setup. I have connected a 100 watt lamp in series with the live wire, so in case we have missed a short, the light bulb will help us detect the short and also protect our circuit from further damage. I am pretty confident that we don't have any shorts. We have measured it with the multimeter, but it is always a good way to be safe when power on the circuits. Now this is power on. I really don't know if this board powers on by itself, or it needs an input from the front LCD panel. I'm going to try to put everything here. Try to measure these pins while the board is energized, and see if we get any voltage output there. So one goes here, so we get, as you can barely see, 10 volts, 9.3 there. So the board is actually working. Just to take one more measurement with the middle pin. Hope we don't short anything. And here is the 5 volts. We will wait for the customer to give us the feedback and see if we had a successful repair. Thank you all for watching. Hit the like button if you find this video interesting, and see you on the next one. Bye.